So hello everyone, welcome back to another event of Aquatic and Fisheries Science Talks. And this is AFS Talk number 50. For those who are new, let me introduce who we are. I am Deepak. I work as a fishery scientist in Australia. I'm hosting this webinar today. With me on board are the other board members. I can see Mukta Menon here. She's a fishery scientist from Seamafara, India. And I'm hoping to get other board members very soon. Dr. Pradesh, assistant professor from Texas State University, and Dr. Sajjana, fishery scientist from SIFRI. Our board members will be serving as co-hosts for this webinar, and so please get in touch with them if you have any technical issues. Let me start with an introduction about AFS Talks. The Aquatic and Fishery Science Talks is an ongoing webinar series inviting speakers around the world to share information and developments in aquatic science. Our aim is to bring science to the public by linking students, professionals, researchers, farmers, and anyone who is passionate about all aquatic things. So this platform is open to everyone who loves hearing a science talk and also who loves giving it a science talk. The upcoming talks are announced in our social media platforms, and the links are available in our website, www.afstalks.org. Now, the rules for the webinar: our webinars are free to attend, but we don't issue any e-certificates. Please keep your mic turned off all the time unless the host requests you to turn on and speak. If you have any questions during the talk, please use the hand raise feature in the Zoom. And also feel free to post your questions in the chat box. We will give you a chance to speak at the end of the talk. The speaker has 45 minutes for the talk and 30 minutes for interacting with the audience. Also, please turn off your webcam while the speaker delivers the talk, but it would be great to see you in action when we have our discussions. Let me introduce the speaker of the day. Welcome, Dr. Jiwan. He is presently working as R&D project manager at Alpha Aqua Limited, located at SB. Is that, I don't know how, is that right?
Yeah, SBA, yeah, that's fine.
Yeah,
SBA.
Harbor, by the North Sea, Denmark. The company is among the world's top 5 technology provider companies for land-based recirculating aquaculture systems. So you probably have heard about it as RAS in short form. Jiwan did his bachelor's degree from Central Agricultural University, College of Fisheries, Tripura, and master's degree from the Central Institute of Fisheries Education, Mumbai, with a specialization in aquaculture. Later, he joined the Ben Gurion University in Israel for his second master's degree in Agricultural Biotechnology, specializing in fish health and welfare. On completion of this, he moved to Denmark for doing his PhD from the University of Copenhagen, Denmark, with a specialization in fish health and welfare. After his PhD, he worked as a researcher at the University of Copenhagen and Denmark Technical University, working on collaboration projects within the fish health and welfare with several industry partners and institutes from different parts of the globe. Jiwan has published more than 30 research articles related to fish health and vaccine-induced immune responses. After a very long career in academia in 2021, Jiwan moved to the RAS industry, and today Jiwan is going to talk something based on his current activity around the recirculatory aquaculture systems, or RAS in short form. Land-based fish farming using RAS has tremendously gained momentum in recent years and is seen as a future of fish production with a reduced carbon footprint, high biosecurity, and a controlled environment for fish growth and welfare. However, RAS also demands high energy input and generates a large amount of waste as solid sludge materials and dissolved nitrogen and phosphorus nutrients. In this project, which is called as Aqua Combine, I guess.
Yeah, exactly.
Yeah, Jiwan and his colleagues investigated the use of RAS effluent water to use them for growing high-value saltwater plants, Salicornia europaea. And the talk will cover the different aspects of this. So I welcome Jiwan again. Please, take the stage. Thank you.
Hi, thank you so much, Deepak, for this nice introduction. I'll hit directly to the topic. Maybe we can take later on discussion if you have questions. As Deepak mentioned, please feel free to stop me while I'm presenting if you don't understand anything or if you have any questions. So today's topic actually is a very nice story. Deepak saw one of our, I think, German crew was filming us future of the future plant material, and he saw one of this advertisement, and he contacted me if you can give a talk on this project. Uh, so I said, yes, I have to postpone some 1 or 2 times. I'm sorry for that, Deepak, but I'm here today. So today's topic will cover, mostly I'll give you overall view of what we are doing, our company's background on the, and this particular project, Eco Combine, what we are doing in this one. We are using RAS effluent water to produce Salicornia europaea, which is one of the high value plant. Or in this project, we are trying to valorize everything from from its green tips to very lignified material. So we continue. So I'm working at Alpha Aqua as a R&D project manager. Alpha Aqua is a engineering company and is a technology provider in our land-based facility. We produce, we make for clients, we design and supply recirculating aquaculture facility. The principle of Alpha Aqua, I will say everything is above ground. We'll not, we don't make big cemented ground or underground piping. We do everything above ground. That makes it easier to handle and for maintenance. And it's, I'll say, it's a plug and play method. This is one of our system we are seeing here on your screen. This we call it NanoRAS system. This part is the where you can see the logo Alpha Aqua. This is the water treatment unit where we have the nitrification chamber, 3 nitrification chamber, degassing chamber. I'll show you in detail later on. Degassing chamber here, and here's a drum filter from the fish tank. Water is coming this way. There's all the sludge material is collecting here and getting rid from the system, and then the rest of the water goes to the, here we have the 3 chamber with a biofilter unit 1, 2, and 3, where the ammonia as a waste that's produced by fish is converted to, it goes through this nitrification process. This is nitrifying, ammonia nitrifying bacteria, and converted to ammonia to nitrite and nitrite to nitrate. Here we have a degassing chamber where the nitrogen gas or carbon dioxide that is produced by fish is taken out from the system. From here, from this chamber, water flows back, and here this is a pure oxygen is added and water goes back to the tank. So this is a basic introduction to our facility. What we do internally is test our own system. Now in this tank, what you see inside is steelhead rainbow trout. It's very similar. Fillet is similar to salmon, a very good taste. And we are doing optimization of our own system, but also how far we can push with the growth rate, development, and welfare, how crowded. Here now they are at 50 kg per cubic meter, and like in commercial, they can go up to 100 kg per cubic meter on the upper side. So we are testing these different things here. This is actually one of the pictures from, not picture, this is renders, but we deliver, I'll say, Ferrari in Tromsø University. We just commissioned our project where we deliver 30 of those nano RAS. They wanted to test tropical fish to temperate and different kind of fish species. So they are fully equipped with different sensors, automation, and all. So we just delivered this project, 30 of NanoRAS. There's a highly equipped NanoRAS. You check water parameter from ammonia, nitrate, hydrogen sulfide, everything. So, and you can control remotely all this system. We also work as a contract research organization where we there are different sensors company that they want to test their sensors in commercial facility like ours. Before going to for the commercialization, they want to have an idea of their sensor, how they are functioning. So they come to us. We are working as a contract research organization. So we testing sensor, biobeads, and lights. One of the this is the denitrification chamber. The new client. This is not here in the market yet. This is a denitrification chamber, and they have produced the biobeads inside the uh, they have, sorry, I'll rephrase it. They have denitrification bacteria inside the biobead, so you don't have this 1 month of time. When you start your denitrification chamber, you start this inoculate these small biobeads made from polymers, and you start the denitrification process immediately. So we do different kind of research. So this is our small lab facility, which I'm heading, and I'm testing different kind of systems here. And we also have LG units. This is a LG bioreactor on your left side, and right-hand side is a LG hangars. We also produce that in Alpha Aqua. So coming to this particular project, which I'll be talking about in detail today, it's called EcoCombine. You can find information in ecocombine.com. And the background of this project is, now we are having less and less farmland because soil salinity is increasing, and where we can only grow, we cannot grow our regular wheat and cereals and other plants we use for our food, producing food. So there are more than 6.7 million hectares of land that's already salt affected. In Europe is 72 million hectares that are considered already getting affected by salt. And 24% of globally usable land is degraded, and it costs around 490 USD billion dollar per year because consequence of this salinity pollution, I will say. So one thing is how we improve our system so that we grow regular food to in this land and without getting it saline affected. And another alternative measure can be to look for plants which can grow well in this kind of environment. Salt-loving plant like halophytes, which are high value and can give produce food or fodder for animals, uh, proteins for human beings, and maybe we can extract different compounds for bioactive compound which can be beneficial for human and animal. So this is in trust of looking for this kind of plant. Researcher, the main project coordinator is Aalborg University. Mete, she has kind of personal experience with the Salicornia europaea. When she was working in Abu Dhabi as chemical engineers, they were trying to use this as a biofuel, and she felt that this plant has many other bioactive compounds. She came to know that, and when she came back to Denmark, she started uh, more research on that, and then they wrote this big project, which was funded in 2019, 10 million euro project, and there are 17 different partners, different universities from Europe, and different companies involved to use different part of these plants to green as a salad, green salad, and lignified to extract protein and to feed animals and to extract bioactive compound. There are different good materials in this plant uh, to extract all those material and use in pharmaceutical and nutraceutical industry. So these are different project goals. There are different very good compounds like hydroxycinnamic acid, carotenoids, and xyloligosaride, which can be ligosaccharide, which can be used for different purposes in pharmaceutical and nutraceutical companies. This extract biocompounds, bioactive compounds from this Salicornia has been found to be effective against cancer, disease like cancer, psoriasis, skin disease. Actually, I'll show you in a later bit that there's already one company, a spin-off company from this project, which has started producing cream for disease like psoriasis, which has rough skin patches, you know. Our part in this project is to use the RAS effluent. When we talk about RAS, it has everything is under control environment. We do it recirculatory aquaculture system, right? We have 99%, more than 98, 99% recirculation of the same water. We use denitrification and nitrification process to convert nitrification process to convert ammonia to nitrate, and nitrate is food for plant. Instead of throwing out or using denitrification, another chamber, like I showed you before, there's also more money to invest for RAS farmers or RAS company, so they can use for producing another high value plant to make economy circular economy based on the circular economy. So you use waste from one plant to or one sector to use as a resource in another one. So in this case, RAS producing high value fish, giving thriving on high protein diet, producing a lot of nitrogen waste and phosphorus waste, which can be used for producing high value plants. So this is our two-layer deep water system. Here, can you see this arrow, that pointing arrow? Deepak, can you confirm me that one?
Yeah, we can see.
Okay, so in this setup, we have this two-chamber, two-layer vertical system. Here we have we call it sum tank. Water will be circulating from this sum tank to this two deep water system, and this we call it overhead tank or buffer tank, where we store water with the fertilizer added in it, or in this case fish water. So whenever there is a scarcity of water down here, it will pump from automatically. We have a low level switch here, so it will automatically ask for water, more water from the top. So it's a kind of automated system, and we have all the sensors sitting here, and it's not visible. In this wall, we have all the display with the control for the sensors. So we have this styrofoam rectangular box with different holes in it. We have in one 83 holes, and we have one with the 128 holes. So all these two chamber, it will consist of around 16 meter square farming unit, right? And then we grow Salicornia in jiffy pots. That's for those who are familiar with the aquaponics unit, this small jiffy pot, that's when you dip in water, it will soak water, and it has all the nutrient in it, and it will swell up like this, and you can put a plant seedling in this. When you grow saplings like this size, and then you can transplant to the this deep water system, this trace. So yeah, when you transplant it, and this Salicornia has around internally, and this are provided with LED light. It has a specific. We are giving. I can give you specific data. It will give around 254 per meter per meter square per second of this LED light on each plant. And so if you look at the investment cost, this is the two rack system here, and the pump and the buffer tank on the top, right? And then one circulation pump, which circulates the water all the time from the from this two chamber raft towards the some tank, and back and forth again all the time. So we have this fish, rainbow trout, in our two of our tanks. We have done preliminary test with artificial fertilizer, 2 cycles with artificial fertilizer. Now we are doing with fish water, directly putting fish water. It's a D-loop system. We have not yet putting water from the aquaponic system to the fish yet, because we want to do all the water quality analysis first and make sure that there's no accumulation of bionutrients, nutrients that's harmful to fish. But we are running as a deloop system, meaning only fish water to the aquaponic unit and to the drainage. So I was talking about, yeah, we are working on the main objective of this project, and what we got from this project is to finalize part, how much
Hello, Jiwan, you're breaking out usually. I think Jiwan lost his connectivity.
can you hear me?
Yeah, now we missed out maybe for uh, 10, 15 seconds.
Okay. Can you hear me now, better?
Yeah, it looks all right now. Yeah.
Okay. So we have two kind of system we are testing. We are with one with the intense rack, one with the less intense rack, and also playing with the different density. We are thinning out at some point of time as a green harvest, and then allowing some to lignify that can be used for different purpose. These are green plants. These are very green plants that goes as a green salad in high-end restaurant. It has a very good price. And the lignified ones, that one is used for extracting these bioactive compounds and extracting proteins. Now, this is intense rough with 128 holes. And from the first production cycle, this is first production cycle is we were using artificial
Hello, Jiwan, we can't hear you.
Can you hear me? Shall I continue or shall I check?
Yeah, 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 we can hear. I think I got disconnected for a moment.
Okay.
Yeah.
Yeah, so this is from the first production cycle using artificial fertilizer. We harvested around 150 kilogram of Salicornia, different green and mature, lignified, and highly mature. And from the second production cycle, yeah, we are optimizing on how much we can harvest as a green because it has a different market value, right? So we have until now we have optimized that, like it takes 4 to 5 days from sowing to germination, and four weeks from when it's grown to is ready to transplanting in the jiffy pot and to the raft in the aquaponic system, and we can start harvesting after 9 to 10 weeks already for the first green harvest. That goes as a green salad for in the high-end restaurant, and then 2.5 kilo to 3 kilo of green harvest per meter square we get until it's mature, and then we can get lignified of around 6 kilo lignified plants per meter square. So, and we are using around 10 to 20, or I'll say in the second, it's 20 to 25 liter per day. That's around 1 to 3 liter per meter square of water per meter square. So we are optimizing in all this parameter and like coming up with the model that how much it will cost to have, our part is to how much it will cost to have this unit, and how much we get as a customer who is doing this aquaponic, how much he will gain by selling green biomass and by selling lignified and by selling very dry biomass. This is when they were lignified plant, and you can see this is they were holding in the brown water. I will say they have very fine root system, very entangled, very intense root system. University people helping us with the harvest, and yeah, we harvest from first batch, I will say 150 kilo, and second was around 160, 70 kilo, but we harvest a lot as a dry biomass. So some of the Salicornia were around 2 kilo total weight. And this was mostly that some of the picture that I showed you before were from the, I'll say, hydroponic unit using artificial fertilizer. Now we have started with D-loop aquaponic system, where we have a fish tank here, water coming from the fish tank. Okay, I'll start from we have a seawater intake here, then we have the mechanical filtration unit, which takes, if there's any dust, we have 10 micrometer drum filter mesh size there, takes out all the small size particles, even sand. And then we have UV filtration, UV treatment unit. So get rid of all the bacteria load if anything is there. Then we have the buffer tank here. From there, we take water to our water treatment unit. It comes to the biofilter unit 1. That's the nano RAS I showed you in the beginning. So we have a biofilter unit 1 here, biofilter unit 1 here, biofilter unit 2, 3, and it goes to the degassing chamber. Well, it will convert ammonia to nitrate, and then here nitrite, some of the nitrate is converted to nitrogen gas, right? Also the denitrification process goes here. So here we take out a nitrogen and carbon dioxide that's produced in the system, in the fish system. So we have all the sensors here. We have the control panel here, and water, after getting added oxygen, it goes to the fish tank. From here, we are also taking water to the aquaponic unit. I can control here how much of water it goes to the aquaponic unit, 10 liter per day or 50 liters per day. It depends. And all the circulated water in the aquaponic unit, we have this sump tank. Is circulated here, and there's an overflow in the sump tank. It goes to the drainage tank. Here I can measure, if I make continuous flow of 50 liters per day, probably they will not use 50 liters per day, but I can calculate here how much of water use in this drainage tank, right? We have water overflow discharge tank, so I can have an account on how much water is used in the aquaponic unit. So we are maintaining our RAS unit with a nitrate level of 80, less than 80 ppm of nitrate, and aquaponics unit we want to provide same to continuously provide nutrient for the plants. And this is we have all the automatic sensors that's uh, uh, recording all the data. So there's over a period of time, temperature, salinity, oxygen, pH. That's in the fish system. No, this is in the aquaponic system. Sorry. And we have same for the RAS system, so we can compare. Of course, we have to, because we are running, we are culturing rainbow trout in the RAS unit, and we have to heat water to 20, 22 degree. We are running 15 degree, 16 degree for rainbow trout, and we have to heat water before it's going to the aquaponic unit. So this is from the present cycle we are running with the fish water. We have, instead of doing one-time cultivation, we are doing batch-wise, because we want to see if there's a difference in batches in relation to production of bioactive compounds. So we are sending these samples to university. So they will look for different bioactive compounds batch wise. We can pinpoint the time. Okay, this is the good time for harvest to get a good harvest of the bioactive compound to extract all the bioactive compound which can be used for pharmaceutical or nutraceutical company. And like I said in the beginning, the final outcome would be data on total production and economics on total capital expenditure, operating costs, and how profitable it is to have this Salicornia production uh, uh, as an aquaponic unit. And then we'll do this upscale calculation. We are going to start a very big facility we call it Alpha Line. So we are going to do this upscale calculation where the volume of water is much in the uh, in this small nano RAS unit. We circulate around 7.5 cubic meter of water. That's the total volume, and that machine that has a capacity to circulate around 20 meter cube. But we have a new system coming, test facility as well, that has capacity of 1250 meter cube of water circulating. So this is the unit I was talking about. This is the mm, water treatment unit here. This is a drum filter water coming from the fish tanks, goes here to the drum filter. It takes out all the solid material and it goes to the degassing chamber, which is very large surface area. We have pattern on this water flow through. We have different 4 plates in it. When water flows through this degassing chamber, all the carbon dioxide is uh, is extracted and it is taken out from the system. And we have this biotar, we'll call it biofilter unit 1, 2, and 3. It will convert ammonia to nitrite to nitrate. And then again, it flows back. Okay, it flows back through here and come back to the fish system here. So this is very large unit. We are going to produce 140 ton of rainbow trout per year in this unit. Actually, yeah, this is facility that I just showed. This is in real. We have 4 tanks here. This is steel tank. Is SDP. This is plastic inside, food grade, and then we have all steel here. This is the drum filter I was talking about. Water is coming from to the fish tank and going to the fish tank. All the water coming from the fish tank is a gravity flow, and we are pushing water from the uh, water treatment unit to the fish tank. It goes through the pump, but water from the fish coming to the water treatment unit is through the gravity. And we have this biofilter unit 1, 2, and 3, and this is a degassing chamber we have here. So we are as a when Deepak introduced me in the beginning, he said our facility Alpha Aqua company is located close to the harbor. We are taking water just from here, 7 meter below from here. And this is another thing we have in our facility. This is not in operational condition, but the plan is to build a vertical system for culturing halibut or flatfish, and to culture, instead of going horizontal, we are going in vertical. Some clients have already showed interest on this to having halibut for production of halibut. So we are working on this as well. And this is one of the company that I introduced to you before. Is a Heloderma company that's extracted very bioactive compound extracted from Salicornia that is used for producing cream. This company is called Heloderma. That has uh, treatment against psoriasis. It has we have a lot of tests going in hospitals treating patients. Also, extract from Salicornia has been mixed with this dairy products like yogurts and all, if that helps in treating inflammatory bowel disease or inflammatory disease inflammation, because that has a lot of anti-inflammatory compound. in a fish trial that's in European sea bass, they have done in the European White Lake stream, they have found expression of a very high expression of anti-inflammatory genes. So they are also doing, like a test of this cream in human, and there are a lot of bioactive compound being tested in other animals. There are a lot of works going on in direction. You can find more information on EcoCombine. There's a lot of more information, 17 different partners involved for because this project is based on circular economy. So using everything from this product, valorizing Salicornia, every bit of Salicornia, using it for producing very dry Salicornia, using it for producing biogas or biochar. Uh, there's a lot of information. If you are interested, you can go to this EcoCombine website, and you can find more information. Yeah, before concluding my talk, actually, I want to highlight this about we College of Fisheries Lembochora Alumni Association and College of Fisheries Lembochora. We are organizing international conference on responsible aquaculture and sustainable fisheries. Called it RASI, from which will be from 13th of December to 16th of December. If you have time, and please visit us, we'll be very glad to have you there. It will be in hybrid mode, meaning it will be also available online. So please join us in Tripura or in a hybrid mode or online platform. Thank you so much for your time and listening to me. If you have any question, please feel free to ask. And this is a view from my office. That's the harbor, Eastway Harbor, and we are taking water from there, very close to that. And that's me taking harvesting green Salicornia. Thank you so much.
Thank you, Jiwan. What a wonderful talk. Thanks very much. So before we go to discussion, can you please provide us feedback for all the audience? I have put the feedback link in the chat box. So it would be great if you can provide a feedback and something for Jiwan as well. And we are always looking to expand our coordinator network. So if any one of you are willing to, help us with circulating our posters and everything, that'd be great. Just get in touch with me or one of the board members. Our website is www.afstalk.org. So let's move into the discussion part. We have 30 minutes. Feel free to ask any question to Jiwan. I will just start with a couple of simple questions before I hand over to the other people. Just a general question, Jiwan, is the project is being done for demonstrational purpose, like to, because I understand it's for developing. It's in engineering, right? The company is in engineering, selling, and so is this project for the company to get into in a large scale commercial production of saltwater plants, or is just for demonstration purpose, to develop the units and show this this is something we have that will work? Is that something?
Actually, our part of the project is to make this a demonstration unit and make economic calculation on it. How much it like capex and opex, and how much we are getting benefit if we connect this system, because RAS is expensive, and also running all this aquaponics facility. We have LED lights, pumps that's running all the time, LED light 12 hours a day. So because now the energy price is really increasing, we were checking yesterday, it has 4 times now, increased 4 times than it used to be. It will be difficult, but we'll come up, it's a demonstration unit. We'll come up with a model like how much it will cost, and if anybody, like there are a lot of interested party already visited this small unit and how much it will cost to make a bigger unit. So to give it to private clients who are interested to, to come up with the final numbers.
Just looking on that system, the lights, is that what will be the color temperature of those lights, the one you use for aquaponics in the grow bed?
That's actually LED light from Signify Philips. Now Signify, and it has it was specifically, we designed this light where they have signified had light in a light engineer. He came, it's because there was like we have for the other LG, we have particular for design, particular for wavelength of light. That's like if you want to produce red algae for production of astaxanthin, then you should focus on this wavelength. We don't have that for any knowledge for Salicornia. So we decided on, okay, this will be the parameter we'll keep. More on the daylight they get in the natural system, because these plants are available in the source of the sea, right? So yeah, on that. So there's not particular wavelength we have fixed. It's a day wavelength is I'll say natural light wavelength. That's, I believe. I can give you, actually provide you specific, like intensity of light we are providing per meter square of the raft.
You showed a picture of the algae bioreactors. Is there something the company sell as well?
Actually, yeah, that's one of my colleague. He designed it. That's a bioreactor, and yeah, we do install. We have sell a lot of other algae bioreactor for universities, and this was a commercially the other bioreactor was commercially used by another company for some years. They stopped doing that, and now we are actually, I'm having meeting next week with the university people. So if we are going to research on biofuel based algae or protein producing algae, so which has more commercial side on it, so we are going to soon that will be also in operation.
One of my last question, so you showed there's two tanks on side of the aquaponics units. One is the sump and one is the top tank or something.
Buffer tank, yeah.
Buffer tank.
So
so when you so you're saying when there's deficiency in nutrients or water level difference?
Water level. So in the lower tank, we have the low level switch, right? And then it's connected to the pump, and it's connected to the control unit. So if the water level goes below this low level switch, then it will ask for a water from the upper tank, which is nutrient water or the fish water with the nutrient. So it will ask for water. So your system will not run out of the water, or
my question was actually because you have the sensors in the sump, and would you get a spike in your because that, I guess the parameters will be slightly different in your top tank, right? So when you get water from there, your sensors are going to show some spikes in the graph. And how do you manage those things?
Actually, we don't have the nutrient sensor. Is the basic oxygen sensor, pH, salinity, and temperature sensor. Nutrient sensor we have in the RAS system. All ammonia sensors and all we have in the RAS system. I'm doing graph sample from those ones. The data I showed, that was from a nitrate data I showed. That's more from the graph sample. I do like spectrophotometric analysis. But the upper tank we know the this much amount of nutrient water we have, so that will take automatically from the upper tank.
Okay, thanks.
Ready to
I just had to first try. Plenty of questions.
I have one more question.
No.
Hi, Brenda. How are you? By the way, how are you?
Good to see you. Yes, I'm fine. I'm fine. How are you?
You doing good? Thanks.
Dr. Prem,
hello, sir.
Please ask you questions.
Yeah, I'm fine, sir. How are you, sir?
I'm doing fine, Prem, sir. Yeah. Is it again disconnected or?
No, it
It's
isn't.
all right.
It is not.
Mm.
Jiwan, how,
Yeah.
are you there? Are you there? You are there, I know.
Yeah, I'm here, but I
Okay.
cannot hear anything.
Okay, so there's plenty of questions on the chat box, and I think Dr. Prem have a lot of questions. Do you want me to read through, or are you comfortable asking directly to Jiwan?
Yeah, okay. What will be construction
Cost
for
50,000
50,000
liters
liter
capacity,
RAS with automation? 50 meter.
50,000 liters capacity RAS with automation.
Yeah.
Okay, it's possible to reconnect to RAS with biofloc or periphyton system, which you are talking to connect with hydroponic system.
Yeah, actually in India, no.
Yeah, yes, sir.
So many people talk about this connecting the RAS with the biofloc system, and then actually we have. I myself have constructed one RAS having the 50,000 liter capacity. Okay, and one of the person from IIT Kharagpur, he was giving one seminar and he started talking on the RAS with the biofloc system. So I had some doubt. Once you fit this UV or maybe the ozonizer or maybe some other means of sterilization, then your biofloc system may not run properly with the with RAS. So what is your comment?
RAS is, I'll say, sir, RAS is more on the how also the one part is recirculation, another part is your water treatment unit. How much of nutrient or toxic waste you are generating in the system by the biomass, and if that is able to convert that biomass to less toxic compound like nitrate. If you have a biofilter unit enough to convert ammonia waste to nitrate, then that's fine, right? And if you can use that nitrate to some to biofloc unit to producing periphyton or some algae, then it should be fine. But we use this ozone generator. We use also protein skimmer, but that's only best for salt water because it will not work in work not so best in fresh water. And UV treatment, that's for controlling the amount of bacteria in circulation. Of course, you have when you have the RAS system, you have a lot of bacteria in the biofilter unit that's also circulating in your tank. There's a ecosystem of bacteria in all your tanks and in your system. So to keep check on those ones. So we have in our system, we have a UV light that's on all the 24/7 that to control the population of bacteria. It should not overgrow or to take care of that. So we have a UV light, but I don't see that's my general comment. I don't see any difficulty in connecting RAS with this biofloc system. If you like amount of nitrate generated by your system, RAS system, you can use it for producing. That should not be problem. But maybe it's problem when you want to reconnect the biofloc water to the RAS. Then you have a lot of solid already in the biofloc system that will be difficult to control in the RAS unit.
Correct.
But one-way system, deloop system, I think you can easily use it, sir. I don't think there should be any problem because it's the same principle as using it for the aquaponic system.
Yeah. Thank you, Jiwan. Thank you so much.
Most welcome, sir. Yeah, most welcome, sir.
There was one more question, Prem, about can you suggest some halophytic plants from India?
Halophytes, I think we have maybe.
Except Salicornia. Salicornia we have.
Yeah, I think maybe that will be best to get answer from local expert. I think we have somebody from the board from CMFRI. I think for if you go for aquaponics unit, that's a bit costly in the running because of all lights and all. That's why we suggests it should be some high value plants where you can use from tips to all parts of its plant, so that you get the money in the end, in return, good money in the return. Sorry, sir, I don't have much knowledge on what kind of halophytes we have, which can be also one thing is what we have, but another thing is if we can adopt in RAS or not. If they can adopt in, not RAS, but aquaponic system, right?
Yes. Thank you.
Welcome, sir. Very nice to see you and talk to you.
Yeah, thank you so much.
Tabas, do you want to come and speak? You have raised your hand.
Yeah, thanks, Jiwan. It was always good to hear you. Yeah, I have a few quick questions. First, start with I think what is the cost of your NanoRAS unit?
Actually, yeah, NanoRAS unit comes with the basic setup and with the all sensors and all automation, right? So basic basic setup starts with okay, I need to convert to
No,
Dennis.
you can tell me in euro. It's fine.
No,
Euro,
actually,
krone.
I have in Danish chrono. Yeah, okay, maybe it's 35, 40.
40K?
No, lakhs.
40
35,
lakh,
34, yeah, I think it comes around that one. Yeah.
Sorry, 40.
35 to 40 lakhs, then 40
40.
Danish, lakh Danish krone.
No, Indian rupees. I'm talking about 35, 40.
Okay.
Yeah, it also depends on, like, because most part of it, expensive part is sensors, right? We have sensor for ammonia, nitrogen to hydrogen sulfide. So the more automation you like to have in your system, price gets higher and higher. So what we deliver,
Upper end price.
yeah, upper hand price. So what we deliver to Tromsø University, I think they got all the sensors, protein schemers to take out the ozonation unit, and all these thing. Yeah, they got they wanted the best, and yeah, we got. I think it was 50, 60 lakhs per unit.
Any idea about the running cost?
Running cost is it takes 2.5 kilowatt hour. So it can be converted to like how much is the electricity price for that one, right?
2.5 kilowatt hour means it's a lot of carbon footprint.
But that's why we are using carbon. Actually, maybe I didn't mention it. We are using carbon from this unit to Salicornia unit to give it as a carbon source. They can utilize. You can utilize for growing plant.
So just following this question, did you measure how much oxygen they are making the Salicornia per cubic meter?
No, we have no measurement on oxygen. We are just focusing on the biomass, actually.
Okay, thank you. And yeah, that's okay. And I saw that you are using the styrofoams for growing Salicornia, and I believe similar to other aquaponic system, the water is flowing downside, and probably. So is it any other pollution aspect you are looking into, or any of your collaborator looking into?
Sorry, what pollution
Styrofoam is a environmentally, I mean, concerning material. So it's there is a lot of data related to environmental pollution. So somebody is looking into that.
Actually, not. You mean leaching from styrofoam or breaking down of
micro leaching?
Actually, we have not looked for that, but we are looking periodically. We are looking for microplastic. We are doing microplastic analysis from the system. Until now, we have to also test our system, if any, because all our system is based on plastic material, right? If there's any leaching from that, but we have not got anything yet. That's a third party. We asked third party to come and take sample and do analysis for us, just to be,
Great.
yeah. So, but we have not seen anything. Yeah.
A very, very small question regarding the Aqua, the AS system, the new system you are designing at this moment with the big tanks, food grade plastic. So which plastic you are using at this moment?
I think it's polypropylene, food grade polypropylene.
Yeah. Okay, PP. So what's your comment about, I mean, changing the plastic material to more, I mean, sustainable material, other sustainable material? Do you have anything in mind?
Actually, we are already moving to this. There's another material called composite or something. We are actually company is looking into it. We are moving already in that direction. Yeah.
Okay. Yeah, that's great. Thank you, Jiwan.
You're welcome. I
Jiwan,
saw some question.
I just have one question just came up. Have you tried any seaweeds to grow in your system?
There was another project we are working in. There's a company who are using because seaweed has a lot of potential. That project didn't came up to the final stage, but yes, we are also looking into that because like when we grow something that there has to be end market, and there's one seaweed. I think there's one company which has market potential market in the pharmaceutical industry. If you have those kind of end users, then you have a good potential for your product. So yeah, we are looking into that as well. Maybe in long run, yeah, we'll dive into that as well. But mostly our focus is, this is one project, and we are doing, like biobit testing and testing of sensor. And our company is more on RAS and, like how we make more automation of RAS, I can control that system sitting from here. It's a remotely access. I can change water to check oxygen and everything. I can look at camera, how the fish are doing, feed, and those kind of things. We are working more on that automation, and also we are working with the company like Siemens, which are doing a lot in Chile, in the like cage farms and all. They are working on artificial intelligence to look at how when the fish are hungry, when fish behavior, looking at the fish behavior biology when they are hungry, how they react, and based on that you feed the fish. So we want to work on those direction in future actually.
Yeah, I don't know who asked the seaweed question. So just a spoiler alert, kind of working with seaweed and integrating with a manageable RAS is a quite expensive task because seaweed needs a lot of space.
Yeah, that was me, Tapas. Thanks.
Yeah, we tried that with ulva and kelp both. So because Japan is a very good market, has a very good market for seaweed, so it's quite lucrative. But integrating with RAS is a really, really expensive affair.
Gokulakrishnan, do you want to come and speak?
Yes. First of all, it is informative presentation. But I have one question. What is chance of getting organic certification from these products?
Actually, I think it's a geography related question. In Denmark, RAS, what you produce from aquaponics, from RAS or aquaculture based facility is not organic, even though your facility, when you provide fish with all organic material, because like it has a very long food chain, like where your feed is coming from, where your protein source is coming from. So it's a very long process. So here it is not organic. But I don't know how is it in India and different parts of the world. Also here in Denmark, we are not allowed to dump aquaculture waste in the landfill or use as a fertilizer because that's considered as industrial waste. I think they have taken up in the EU. I have been in another meeting last week, and they told they have taken up this matter in EU Commission. Probably we'll see some changes in future, but now we are not allowed to use as a fertilizer waste from aquaculture. So I think it's a very geography specific. I'm not sure how is it in India actually.
Yes, here also we are facing only if we are using plastic materials in system. Here local authority, they are saying it is not coming under organic. So, but there is, we are here having some different kind of culturing technique. We don't use fertilizer or we don't use any in pesticide or insecticide, but there is no difference between our products and locally available local market products, because we are spending some money to keep infrastructure. So is there any separation from normal locally produced product and our products produced through aquaponics?
Difference in terms of, you mean nutrients, or what you are talking, or quality? What is your specific question is about? Sorry, I didn't get it completely.
Actually, in market, we have to compete with normal producers price.
Yeah.
So there is no up to now there is no separation or no category that we haven't used pesticides or anything fertilizers, inorganic fertilizers like that. There is nothing separation between these two products. So we have to sell it in normal prices. So
I think it's also, you know, like a knowledge base. I think aquaponics is gaining the market quite enter into the market quite recently, and people don't know much about it. I think it comes through, you know, like when people get to know this thing, how food are produced. Like now, young generation, I'll see, you know, like they are not interested in which food it is, but they are interested in how they are produced. Not on the quantity, but how they are produced, right? So if we come through advertisement or make them, you know, like aware that what we are doing, how we are producing is safe compared to the other, because we are not using antibiotics or any harmful spray or pesticide in it. So I think it will be, it will take time. It's like a RAS, you know, like when it, I think RAS started long back. It's still gaining popularity, and I think it's takes some time for people to accept it. You know, like Atlantic sapphire and this yellowfin kingfish, they are doing great job putting a lot of advertisement of how fish are produced. We are taking care of fish welfare. We are not making industrial production, but producing in a good environment, and we're not putting into antibiotics that you know, like in other culture facilities they do. So I think it will take some time, but I think we should also focus on making people aware how we how they perceive things. They change their perceptions.
yes, thank you, sir.
Okay. Did I miss there was some in the
Yeah, there is questions. The next one is by Ipsita Biswas. It was a nice presentation, sir. How far this type of technology is applicable for small and marginal farmers of India? What is the future prospect?
I'll say, yeah, that's a very nice question, actually. Indian perspective. I always think of Indian perspective. I think we are not there yet, because this is, I'm working with this system. This is very energy demanding. It has a lot of maintenance in terms of, you know, like you spend a lot on sensors and all, but of course not for small and marginal farmer. But I think if big players come to market with big investment with the high value fish, salmon, or we got client last to last week. They wanted to do tuna, actually. How feasible is that? We don't know. We are looking into the project. There we get different clients. They're visiting us, and we want to do this fish. So fish has to be really, really, really commercial. That's the end product you are selling. And because per kilo of fish in the end should give you more value, because you are spending a lot on energy, maintenance, and staff costs, and, you know, the feed costs. So it's a lot on RAS, you know, like a lot of money you invest on RAS, and so high investment. But for smaller farmer, I'll say that, you know, like not high-tech RAS, one can do with the low-tech RAS and connect with the aquaponic system. It doesn't have to be, you know, like everything should be controlled, like I think people are doing with tilapia. So focus should be on if you are producing iceberg or like lettuce or something. So I think we can always do with the small production system like that.
Any clients from Australia, Jiwan?
Australia. I think we don't. We received some requests, but not somebody visited us. They wanted somebody wants to do it Hawaii, and somebody in Caribbean, and yeah, a lot of not from Australia.
So yeah, can you share your email ID, Jiwan? So if people have more questions, they can contact you. I should have told you before to put that thank you slide, but you can type in the chat box.
Yeah, I'm doing it right away.
Yeah, thanks. So someone have asked to send the PowerPoint to email. We don't do that at the moment, but if Jiwan give his consent, we'll put this in YouTube. Only if he comes.
Let me think. Let me think. Some of the slides, maybe I'll take it out. Some of the construction slide. That we are doing. That's a kind of internal thing that I wanted to share with you. That's my email ID. Please feel free to write to me, or even in the personal one. It may take some days. I answer you back, but I'll definitely answer you.
All right. You did send as a personal message, did you, Jiwan? I thought.
Sorry?
Did you send that to it's not for everyone, I think. Did you send a personal message?
Oh, is it? Okay,
We
maybe,
cannot see in the chat box.
Oh, sorry. Okay, there was something. Yeah, it was for. Okay. Yeah, maybe now it's. Ready, right?
Yeah, we can see that now. Yeah. If anyone else have a question, you can just unmute and ask Jiwan. The RAS unit you showed have 3 biofilter units. So what's it? Is there any difference between the 3 units?
No, we just wanted to separate, so that we can run independently. Sometimes we run it as a fixed bed, and sometimes we run as a moving bed. We can separate so that you can isolate the chamber and run it as a moving bed, 2 of them, and 1 as a fixed bed. So in the last chamber, now we are running as a microparticle filter. That means we are not giving any air in that one. So it will be catching all the small particles. We are using 40 micrometer mesh in the drum filter. So you have small particles we are trying to catch there. So improve the water quality.
Oh, okay. So it's you can bypass any one of them if you want, right?
Yeah, and we can also clean individually. So there's an individual outlet for it, so we can clean individually.
Yeah.
So other one that I showed you, there's a very interesting thing we are doing for. I'm not allowed to reveal the company. Very famous company that we are doing. They came up with this idea where they have a bacteria inside. Denitrification bacteria inside, and this one, and this is if this it's working very nicely. So this is very small, and you can reduce the size on the biofiltration unit. Small amount of these beads will take care of all your nitrates and ammonia waste, actually.
So they come with some bacteria inside.
There's inbuilt bacteria inside. Yeah.
Okay. So what's the life of this product then?
So we are testing that. It has been tested with hydrogen peroxide and also peracetic acid, which is a common disinfectant in the RAS unit. So they are, I think they are okay. They are doing good.
Those 2 colors, they're 2 different things.
Actually, it's the same thing, but density-wise they are different. The green one is a bit heavier, and yellow is a bit lighter. Because like when you have a moving bed and fixed bed, we have to play with also density of biobeads or beads you have. Yeah.
What do you think? What's the exposure time of water to these beads?
So the hydraulic retention time for this one we are keeping now is around water will, this is 200 liter bioreactor, and water will stay, and we are making a flow of around 120 liter per hour. This is just for this test, and I think 45 minutes, I think. So. But there's also, we have another project where we are working on, like all the waste that is generated from RAS as a solid waste, if we can use it as a fertilizer, small, like garden fertilizer. So we are working with Denmark Technical University on that, and small, we call it fish cake. Actually, it can be used as a garden fertilizer if we can add some other nutrients and make it as a fish cake or garden nutrients. So we are working on all the waste materials so that there should not be any waste from RAS, because that's the big thing. The RAS we are talking about 5,000, 10,000 tons unit. They ask for clients, and they also generate large amount of solid waste and large amount of the soluble waste. So we should also take care of that. That will impact on if they will have license for 5,000, then how much nitrate they are dispersing into the environment, or how much treatment unit they have. That will have impact on the license also. If we have the solution for nutrient treatment, then they have the license for more fish production. So yeah, we are working on different those solutions as well with the universities and other private companies.
That RAS unit, the degassing, what exactly is that doing? Degassing is
because we also produce, like farm fish, very highly dense populated fish, produce carbon dioxide, and also there's some denitrification goes in the nitrification chamber, because it's a mix of bacteria you cannot control. There's also nitrogen gas produced. So we have a vacuum system there, and when it's water is falling, we have a special pattern on the other unit where water is falling from specific height. The vacuum gas is sucking all the carbon dioxide and nitrogen and taking out from the system.
Okay, all right.
So you don't have accumulation of carbon dioxide, which is toxic to fish. That's a very important in RAS system.
What happens if one of these fails? Is there a backup system within that unit, or?
Yeah, actually, there is RAS is more on redundancy. Like you have a lot of redundancy in the unit. If the one system fails, then there should be always another the backup. And if anything happen, if pH goes high, if temperature goes low or high, if salinity is higher than the level limit, so you always get alarm. So on your mobile phone. So that's more, and I can adjust from sitting here.
Yeah.
How often do you get the alarms?
Well, not so much. If there's something wrong with the system, then of course you get it, but not with the regular one. But some time back, what we get alarm for, it was, I think, no, not the major alarm. It will be something like not life-threatening for fish. If something with oxygen, of course, you have to respond immediately. If something with the temperature that's not so high, but instead of 14, we have the set point of ±1. If it goes 16, it's not killing the fish. So right, so it can wait. But I can always change the water and change the alarm system setup from here.
All right. So
and we have this. This is the lab here, and all the clients they have an upper panel balcony view. They come through this gallery. There's a door here, because we maintain one of the things for RAS is to maintain very high biosecurity, so that all the RAS farm do, so you don't have any disease introducing in your system, so pathogen introducing in your system. So we maintain very high biosecurity. We allow people to keep, because this is a display unit, we allow them to have a view from the top, from that viewing panel, that veranda we call, or some very specific like people from company who are other company who are working very closely, so they can get a very close view.
So with this, one of the nano RAS system, for example, how much fish yield we can get in one cycle?
Yeah, so this nanoRAS can handle 20 meter cubic water flow per hour, right? So if you have 3 tanks or 2 tanks with 9 cubic meter, that's 18 cubic meter, it can handle. That's 18 cubic meter of water. And if you have maximum velocity or maximum stocking density achieved would be, if it is 100 kg per cubic meter, that will be 100 into 18 ton probably.
Yeah.
1.8, yeah.
Do you think this work with oysters?
Sorry?
Do you think this work with oysters?
I think this RAS is just like main part is a water treatment unit, right? So if you have the water treatment unit, you can connect any pipe to tanks to that. If you have the water treatment unit functional, then it works with anything. I have seen like new system design with the where you have this kind of rack system for the oysters, or was it for lobster or oysters, and then rotation like this where they come on the top and the automatic feeder, and then it goes down. There's a lot of things. That's what I was saying you in the beginning. We are in very exciting time. There's a lot of happening in the aquaculture sector, a lot of automation, a lot of new development. I think we'll see a lot of new things soon in 5 years period.
All right, so we can wind up, I think, almost 1.5 hours. So thanks very much, Jiwan.
Thank you so much for having me. It's a very pleasure talking to you all.
Excited to see this project. Yeah, and very excited to see you after a very long time. But yeah, please join other talks, and also maybe at some other point we can bring you again for having a different. When you jump into the next project, we'll bring you again.
Sure, definitely.